episode 5 of Daryl, Show Your Work. In this episode, we'll be covering the subject matter of obfuscation. All right, so I'm going to be showing us different obfuscation techniques, mainly dealing with steganography and also with a symmetric cryptography. So I'm going to, for the next, I would say, 2, maybe 3 videos, we're going to be on this subject matter, mainly dealing with cryptography because it's such a vast subject area, and there's types of different types of encryption algorithms that are used for different type of purposes. And I want to make sure that I display as much as I possibly possibly can. So in this video, we'll just be covering steganography and symmetric cryptography. So to get started with steganography deals with taking something like a regular image and hiding information behind that image. That basically plays into the definition of obfuscation, which basically is we're finding ways to take regular plain human readable information and hiding it. And hiding it could be behind a image file such as using steganography, or it could be behind ciphertext when using an encryption algorithm. So I'm going to start off by covering steganography. So the first thing I'm going to do is I'm going to change directories to where my image that I'm going to be using in my example steganography is stored. So I'm changing directories to desktop challenges and then steganography. All right, then enter. All right, now I'm in that directory. All right, the first thing I'm going to do is I'm going to bring up I'm going to show you the JPEG image that we'll be using to try to see if we can pull some human readable information from. So I'm using a software called in order to accomplish this. I'm going to be using a software called Steghide. So Steghide can be used to hide the plain text information within the image and also to extract it from it. So if, let's say, there was suspicious email communication going back and forth either within the network or going back and forth from someone within the network to someone outside the network. But all I was seeing as an administrator or as a cyber analyst, all I was seeing was just image files going back and forth. That would look suspicious. So I would use a program like Steghide to see if I can extract any sort of information from that, to see if, hey, are these two people that are communicating or colluding in some sort of digital crime by communicating through some sort of communication channel, just using images and storing those clear text human messages within a file. All right, so to continue on here. All right, so I'm going to do EOG clue.jpeg, and what this is going to do is just going to show us the image that we're going to be working with here. All right. Sorry, so there's our little detective. All right, now that we've seen that, I'm going to close that out. All right, now I'm going to use Steghide to try to extract any type of human readable language from that image, and then I'm going to store that into a text file. And then we're going to read that text file to see if we were able to indeed extract anything from that picture of our little detective. So I'm going to start off by writing Steghide. Then I'm going to do it extract SF parameter, and then clue .jpeg, 'cause that's the file we're trying to extract information from. So I'm gonna hit enter. All right, and then my passphrase here, enter that in. All right, so it's telling me, Steghide is telling me it's extracted the data and it's outputted to a text file called hidden.txt. And we could check for that file in our directory by listing. And as you can see there, along with the clue.jpg file that we've extracted information from, now we have a new hidden.txt file. So then I'm going to, in order to display what's in hidden, I'm going to cat hidden.txt. Oops. And voila. So this is what the human readable language that was stored within that image. It was steganography. But in a real life example, it could be two people that are colluding in, let's say, fraud. And somebody is telling someone like how to hide some information or how to play with numbers or whatever, where you can use something like a Steghide in forensic investigation, as far as trying to extract those hidden messages and helping build evidence against someone who may be doing some type of criminal activity or who may be doing something fraudulent. So that's an example of how you would use steganography in the real world. So next thing we're going to be doing is moving on to symmetric encryption. So symmetric encryption is basically when we take clear text language and try to hide it behind ciphertext, which encryption accomplishes. So in symmetric encryption, that uses just you use one key to both encrypt your message and to decrypt your message. Where asymmetric cryptography, you would use a public private key pair, where you would use your private key to encrypt something, and then use the public key to decrypt. I'm sorry, you would use a public key to encrypt something, and then use a private key to decrypt it. So, or it could be one way or the other, depending on who's sending the message or who's receiving the message. So just know that you need two key pairs to either to encrypt your file and to decrypt your file. Okay, so but in symmetric encryption, we're going to just be using one key to do both the encrypting and the decrypting. So in order for us to move on to this step, we're going to do period. And what this is doing is saving us some time as far as having to write the whole directory out when moving up a few layers within our directory. So instead of me having to write desktop challenges all over again, I'm just going to write ... and I'm going to write cryptography, and then symmetric. And this saves me some time as far as like having to write the whole thing out. And again, it moves me a couple of just folders up within challenges up to cryptography, and then symmetric. All right. So in this directory, I'm going to show the files we're going to be working with. All right. And then just to briefly go over what you see here, you see 6 different files here, all encrypted with 3 different types of symmetric algorithms, but in 2 different modes. So you have, I'm going to list these out from most secure to least secure. So most secure is your AES file encryption, and then behind that is 3DES, and then there's DES. So AES is the strongest out of these 3 algorithms. AES right now is the strongest out of these 3. And then without going too far into the weeds, just know there's 2 different modes that you can encrypt these files in. And I'm gonna go through encrypting them in each mode of the 3 algorithms, and decrypting it in each mode of the 3 algorithms. So what we can do is what we're going to store some ciphertext files in this directory into a text file. So, and then these are the files that we're going to be using. So to do so, I'm going to do AWK. All right, then and I usually leave these commands that I'm writing. I use them in the usually leave them in the show notes, but because YouTube has such good input validation, some of these characters I cannot like actually like write out into the show notes section, again, because certain characters you don't want to actually have on your be able to have in your text box, because then it can allow the execution of code, which we'll go through in a later video. So what I'll do is things such as like the greater than sign or the curved brackets. I'll try to describe that the best way I can in plain text for you to understand what it is that I'm telling you to write. But it is going to be a little challenging since I cannot like literally like write these actual like characters out, because they're basically sanitized from me being able to write them out. Okay, this salted. Um, so basically, I'm going to be saving. Basically, I'm going to be saving some ciphertext into an output file known as salted.txt. So I'm gonna hit enter. All right, and then let's read the contents of salted.txt. Let's see what we got here. Okay, so what I've done, as you can see that you could clearly read when I showed you these list of files, these .enc files. These are six of them. When I showed you this, you could clearly read. They say 3ds dash cbc, so on, so on, so on. So what I did was I took these and I told it that, hey, print these out, but also encrypt these and put the output into a salted.txt file. And so when I catted that, what it's doing, it's basically it within these files are that it's the actual method of encryption that you would use to encrypt the plain text. So when I put this command in, it actually encrypted all six of these in the actual algorithm and mode in which they're displaying here. So, example, the first file, 3ds-cbc, that was actually encrypted using the 3DES symmetric encryption algorithm within the CBC mode. Three in the second file, 3ds dash ECB was encrypted with the 3DES encryption algorithm and ECB mode, and so on and so on. So that's you're just seeing what you're seeing is what those plain text file names look like when encrypted in their respective algorithm that they're representing. All right, so now we're going to move on to using a piece of software known as SSL. So this is a command line utility to generate private keys, encrypt, decrypt, create certificate signing requests, generate certificates, and identify certificate information. So we're going to be working with this when doing our symmetric encryption. In fact, all the most of the encryption algorithms that I'm going to be showing you throughout these series of videos dealing with cryptography, we're going to be using an open SSL command line utility. So the first thing we're going to do, we're going to begin to decrypt each one of these files using OpenSSL. It's going to seem kind of repetitive or redundant, but I just want you to see what commands we use in order to do this, so you'll be able to pick up the pattern. You'll get the basic gist of what we're doing and how we do it. So first thing we're going to do, we're going to start with the first file. First thing we're going to do, we're going to say open SSL. All right. And then I'll write ENC, and I'm going to define the encryption algorithm that I want to use in order to decrypt this file, which is DES-ECB. So I'm defining that here. Hold on, I'm sorry. I'm defining that here, and then now I'm going to tell it which file I want it to decrypt using this algorithm. And that's going to, as you can see, that's going to be the file name of the same type. And it's going to be the .enc file. And then I'm going to tell it, I want you to output, I want OpenSSL, I want you to output this to a file called DES-ECB.txt. And this is where the clear text version of what's in that file is going to be is going in. All right, so I'm gonna hit enter. All right, so hold on, it should have asked me. Yeah, hold on, I think my syntax may be a little off there. Let's see, where did I go wrong with my syntax? Because it should have asked me some questions there. Open CD dash. I see. And this is what I mean about your syntax has to be on point, or else your Linux tools won't work the way you want them to work. There we go. All right, so let's give them a password. All right. So, all right, now we're gonna read this file and let's see what the plain text was inside of this file. So, okay, so we're gonna do cat des-ecb.txt. And there we go. So what was encrypted inside of that file, the word cryptography. All right. So we're going to move on now to the next file. All right. So instead of trying to write this whole command out again, we're just going to go back into history by pressing my up key on my my keypad. So I'm going to make some adjustments here according to the algorithm that we're working with. So the algorithm we're working with now is still DES, but it's the different mode. So now we're working with the CBC mode. So I'm going to put CBC everywhere where there was ECB. All right. Then we send the CBC. All right. Let me hit enter. Enter my password. All right. And let's, again, go into my history and just make my adjustment here and change that to CBC. Oh, that said cryptography too. All right. So those are 2 files down. Got 4 more to go. All right. Next one we're going to be dealing with are the 3DS files. So we're going to be doing the 3DES dash ECB file. So all right. So go back in my history, and we're just going to change these accordingly instead of writing everything out again. So let's just add a 3 in front of here. You know what? I got a better idea. We're going to go back even further. There we go. So the only thing I have to do really is just add a 3. Add a 3 there. 3 here. And a 3 there. All right. Okay, well, maybe it wasn't that simple. Let's see. All right, let's see. Where am... okay, there's something in the command. So we have to do something a little different when decrypting 3DS. All right, so let's see. -3. See, what should be here? Okay, I see. All right, so let's DES. Let's try this. Then we're going to say EDE 3-ECB. All right. Okay, let's see. Make sure my syntax is right there. DES.3. Okay. So let's see, does that do the trick? Yep, looks like it did. All right. All right, so then we're gonna add the 3 here. And let's see what this says. Cryptography. All right. All right, so pretty simple. All right, so we're gonna move on now to the what are we on? We are on file number 4. All right, go back to our command here. All right, let's see. All right, so we're going to now be working with file 3DES cbc.enc. So, all right, so let's change this accordingly. So let's see. So we need to change this to CBC. All right. CBC. CBC. All right. Hit enter. Great. So my syntax is right the first time that time. All right. And then we're going to read this. So let's do CBC. Enter. Cryptography. All right. So we've gone from weakest algorithm. So if you've been paying attention, we're going from weakest algorithm to strongest. So we've started off with DES, which is the weakest. Then we have 3DES, which is moderately strong, but both are considered legacy symmetric encryption methods. And now we're going to go to the strongest, which is right now considered the standard when it comes to symmetric encryption with files that are at rest. And when I say files at rest, I'm talking about files that are currently like stored on our hard drives, or stored within the network. They're not files in use, meaning that we're not currently like using the file, or they're not files in transit where we're sending the other files like through some type of communication method, like email, for example. Because there's a whole different type of way of protecting emails that are in use, or emails that are in transit, again using email or some type of, or sending them across the network wirelessly, or that's a whole different set of encryption protocols that we won't be going over today, but just wanted to make sure I mentioned that. All right, so moving on to the AES encryption mechanism. We're going to be dealing with first with the AES ECB file that's encrypted using that method. So in order to begin decrypting that, we're going to, of course, well, let's not do that and take my own advice here. We're going to go back in our history, and then we're just going to modify our command accordingly. So let's get rid of all this 3D DES stuff. All right, and then we're going to put our AES related commands. Sorry, that. All right, so what we're telling it, we're telling it that, hey, we want to decrypt this. We want to decrypt a file that's using 256 bits, which is a pretty, I would say, pretty strong encryption algorithm. The more bits, the more secure. All right, so, all right, let me say in. Okay, we want to make sure we have the right file name here. So our file name for this is AES.ECB, because that's the encryption algorithm we're working with, .enc, and then we want to make sure the file we're creating is one that is in line with the naming mechanisms of the files that we're already using in the encryption method that we're using. So, all right, everything looks all right. So let's make this, let's see. Great. So I'm gonna put in my password. All right, so then let's, all right, so let's just change this to AES. All right, and hit enter. Cryptography, that's what's inside the file. So it looks like all these files, they just keeping it simple. All of them have the word cryptography in them when we decipher them. All right, and then we're finally on the sixth and last one. So, all right, so let's decrypt this last file here. All right, so in order to do that, we're just going to change this from ECB to CB. Again, this is just same encryption algorithm. It's just a different mode. So I'm going to say CBC. Then make sure our file name that we're creating lines up to that, CBC. All right, great. Syntax is perfect. All right, and then let's see what this turns out to be, which I have a strange feeling that it's going to say cryptography too, but we're going to see. Ah, there we go, cryptography. So, I mean, in a nutshell, this is like the basics of symmetric cryptography. We use one key to not only encrypt our files, but we use the same key to decrypt our files. We use I showed three different encryption algorithms without going too deep into the weeds of what necessarily differentiates them. The basic thing to know is that which is the weakest, which is the strongest. AES is the strongest, 3DS is somewhere in the middle, and DES is the weakest, but both 3DES and DES are considered legacy symmetric encryption protocols, and AES is the current standard. All right, so this brings us to the end of our video. In the next video, I will be going over asymmetric protocol, encryption protocol, and I also will be covering elliptical curve. Both are a key pair of protocols, and I'm going to show what encryption looks like dealing with those. Well, until then, please like, subscribe, and share. But most importantly, share your work as well. And I wish you Godspeed in your cybersecurity learning.